about integrals and volumes and areas, and we're going to have a fun time. And in the case of a pyramid, oh look! I have a pyramid right here. I can take the pyramid and divide it into sections and slabs, and each is a thin, up and down little square. But each looks like a square, but it's a square. Oh. The squares, they have a little thickness and a little slabbiness, if you will. Now, when the squares get smaller, as we get to the top of the pyramid, or you could go down. So, when you envision the pyramids, you don't think of a smooth surface, but more of a jagged surface with the steps, like Egypt, where they go down and out and down and out. And the steps, they get bigger in the areas, and they all have a certain thickness though, known as delta H. Now, the delta H, it gets crap! Every freaking time the screen turns off! Cut the camera! My screen's working, friggin' director over here screws up. We can get back to our integrals and pyramids and slabs, okay? Gosh. So, as you take these slabs, you want to interpret these slabs and multiply them and add them up, and you want to interpret this into terms of an integral. Now, if we don't remember what an integral is the opposite of the derivative. It's the area of the figure. And when you take the integral, you get the area and volume of geometric shapes like such, like this pyramid that somebody turned off. Whenever we write this in terms of the expression, where each part of the sum is accomplished by multiplying a dh by the area A, the dh being the heights, and the A being the changing area. The area is we talked about this the slabs that we create by this picture here, and the ever-changing areas. And then when we multiply these, you get the integrand and the integral. Now we try to look at this red highlighted slab, and the slab is red because we're going to try to use this slab as the model slab for the whole slabbed pyramid. Now, if we take the slab, we make it a thickness delta H, and we multiply it by its area, and when we add all the areas up, you get a formula with an integral like this. Now, the algebra is much easier going from the top to the bottom. Now you see, I made it so that the height and the base are 200, so that when you go from the top to the bottom, you get the distance from the bottom to the top is the same as the perimeter and area around such slab. So now when you take this red slab and you incorporate what I said about the height and the sides being the same height, you get the slice and the slab being 2h squared delta h, and that's the volume. And when you try to add all the slabs together, you get an integrand of 0 to 200, because you know the height is 200, of 2h squared dh, and that's the area of such pyramid. And with all these slabs, you are done. And now once you get this equation, we are done. Yay slabs, and we are finished with our pyramid of calculus.
has appeared that I've urinated within my drawers. Oh no.